I hope you had a fruitful discussion about LLMs and programming in the lunch. And now we are moving on to the afternoon session. The first session is more about document-oriented programming and beyond. The first talk is about document-oriented programming based on edit history by Tomas. So please go ahead. Thank you.
Thank you. So I'm very happy to see that there's an entire session about document-oriented programming, because I think this is a theme that I found very interesting. And so I'll tell you a little bit about my work in this area. This is kind of paper or a video that I did that came to existence in parallel with this work that Thijs presented earlier on the challenge problems. So it's sort of an attempt to address one of the challenges that we posed in that paper. How did I get here? So first, let me tell you a little bit about the kind of programming systems that I want. So sort of vision behind this is that I want something that's accessible and simple on first encounter. Idea is that if you sort of have a program created in a programming system, I'll talk about systems rather than languages, then you should be able to sort of approach it, do simple things with it, even if you're not an expert programmer. But also, I want something that allows the power users, the actual sort of expert programmers, to do whatever they want, modify the system. And this should be something that can be used for collaborative editing, and it should be open in that you can sort of use the system to explain why you got the results you got, or where certain properties of what you see on the screen are coming. So for example, if you see a sort of green and red color somewhere on the screen and you want to change it for accessibility reasons, you should be able to sort of use the system to trace where this is coming from. So it's kind of an idea for a system that in some ways I think has been envisioned by the Smalltalk people in the 70s, at least in the early days. And what I'm going to talk about today is two ideas that I think if you combine them together can get you somewhere in that direction. The first, and that is nice to see as this has become a theme for the whole session, is to represent sort of everything you have in the environment as a document. Here you can take inspiration from things like Smalltalk, which had the image-based format. But there's also other sources like the Boxer programming tool, which you can see on the screenshot, where everything in the program is sort of exists somewhere in a document. So this is really my sort of first key idea. All your program, all your code, all your data will live in a document. And imagine something like an HTML page where, or maybe you can collapse some part of it. But the key idea is you can sort of navigate through it and find everything. And as a bonus point, this could also contain not just the code and the data, but also the evaluation trace of the code. So if you run something, it proceeds in some steps, and those steps you should be able to store in the document as well. And that then you can use for doing this inspection and sort of from within the document find out how things were calculated. That's the idea number one. Idea number two is to represent program as a sequence of edits. So what I mean by this is that when you program, when you're creating this document, of course you could just store the current state of the document. But then it becomes quite hard to see how things were created, and it also becomes a nightmare to merge diverging documents. So if we instead, sort of every time you interact with the document, you add some nodes, add some code, run something, all of these things will just append interactions to a list. And then you can, hopefully this makes merging of documents easier, and you can analyze the previous edits to sort of see how the document was constructed. So all my demo here is going to be around this conference planning example that I talked about earlier. hopefully you I don't have to repeat that. But the idea is we've got some conference organizer, conference planner, or that's the task we want to do. We want to organize a conference, and we want to invite some speakers, and multiple chairs of the conference are collaborating on this. They suggest some speakers, then they calculate some budgets. That's the work they do. And I've got this demo here that I'll show you in a second, where on the left you can see the document, and on the right there's a preview of all the edits through which the document was created. One of those is the currently displayed state, so you can navigate through this and replay the history. And to actually show this, so I haven't really implemented any fancy editor for my documents. Instead of doing any editing, I'll have a couple of buttons highlighted in green here at the top that basically replay some hard-coded edits to the document. And important thing that I'll get back to later on is that they all start with the same baseline document. So if I go to my demo, then here's my baseline document I created, and you can navigate through this. So I added the title, then I added subtitle, then I created the list and added a few people to the list. And so the first challenge is what Thijs has been describing, where I can imagine we've got two people. One is adding a new speaker to the list, and the other is refactoring this list to become a table so that we can then track other things. Those two buttons I've got here, they will add more edits on top of this baseline. And if I click both of them, then they have to be merged in some way. So let's first see what happens when we add a speaker. So this has added a speaker, and I can now replay that. So first we add a new speaker, and then we sort the names. And then the other person can come, or their machine connects, and their changes synchronize. And what they have done is that they refactor in a couple of steps this representation to be a table. So now I've got a table here. And this did some retagging and wrapping and so on. So there's a couple of basic operations in play here. Now, the other interesting thing is that, of course, if the changes were merged in the other way, then we first refactor. So given the original list, we turn that into a table. And then what happens when we add a speaker? So naively, this would just append the list item somewhere. But the clever thing that the system is trying to do is that it reconciles the edits. And as we are now adding the new speaker as an edit after all those previous edits to refactor the table, the edits to add the speaker get transformed along the way. So they actually become an edit that appends new table row and then reorders the table rows. So this is a thing that has happened behind the scene automatically for us. So to some extent satisfies the first task that we set. So again, the important thing here in the demo is that I've got this green bit at the bottom, that's my baseline. And then on top of that, I can replay various other edits, like adding a speaker or refactoring the list. And this is kind of a typical local first scenario where maybe you work in a disconnected mode, and then you need to reconcile the edits coming from multiple sources. And in this example, I had two different ways of merging, where we take the baseline and then we either refactor and add a speaker or add a speaker and refactor. And for the second edit, like on the left, the adding a speaker, that has to be transformed to be consistent with the refactoring that's happened. On the right, we add a speaker, and then the refactoring has to be consistent with adding the speaker. And there's a couple of interesting theoretical questions that I've sort of not really driven deeply into, but do these two sequences result in the same document, or can we have some edit that will impose a conflict so that we can then only merge one way? I can tell you that in my demo, I have a test that checks that the two documents are the same for the samples I've got, but I only tested that, and I have no proof that this will work. So this was the document editing part. The second part of this example that I've got is that you can also include code in the documents. So inside the document, you can write some formulas, and the formulas are really represented just as 3 elements of the document. So everything here is a tree, and in my view, they will be rendered in a somewhat nicer way. Of course, then we have lots of interesting other problems. So this is a sort of illustrated screenshot of a thing I'll show you soon, where we now have formulas in the code. They're not rendered super nicely, but there's this little sort of expression here where the key thing is you can refer to other elements of the document. And there's some built-ins like count and multiplication and sum. But there's all these references which you can sort of think a bit like a CSS path or a navigator that refer to the first purple example right here at the top that says select all the speakers. So take the speakers section of the document and then select all the elements, and then we want to count them to get the total number of speakers. Then we do some other calculation, like the speaker travel cost will be the number of speakers times some fixed cost. The cost for coffee breaks will be the number of attendees times the baseline cost of the coffee break. And then the final total sum will be summing all these sort of intermediate sums. So you can write these selectors. And this is something that I think, together with Jonathan, we've spent a long hours discussing what you can actually select to make the merging then work. So this is maybe a sort of another lesson from this, where I think my selectors are a bit more flexible than what Jonathan has been working on in some other projects, but that also means my merging is a lot harder. So let me actually show you this. Again, I start with my basic speakers list, and then I've got this button that adds the budget calculation. So let me just replay all that. And this was just adding all these formulas. And I can also evaluate. This actually I can sort of do step by step. So it sort of proceeds from top to. So as you sort of do this, first, the arguments where there's a path selector, they get replaced by a copy of the actual value, and then that gets reduced, and the same thing happens sort of on and on. Now we multiply 5 times 10. Well, I can sort of just click eval all and replay that for you. So now the formulas have been evaluated. Now, the interesting problem, again, is this merging. So if I add the budget calculation, so this is sort of one person adds that, the other collaborator, the other co-chair, adds instead, or does the refactoring to a table, then we have an interesting problem, because the refactoring changes the structure of this list. And so all these nice references, like all the speakers, it is kind of tricky what to do with them. So here, as I do the refactoring, you can see that this is changing as well. because we have a wrapping operation that wraps the elements in a sort of sub-element, and the wrapping is not applied just to that list element, but it's also applied, it's basically sort of applied to all the selectors in the document. So the selector changes because now we sort of suddenly inserted body table or t-body into the document, and that we need to kind of count the rows inside that. And of course, this has to work the other way around as well. So if I do the refactoring first and then add my budget calculation, the budget calculation is already using the new correct path with respect to that refactoring. So this is kind of an interesting issue where you really have to take account of these formulas in the merging operation. So the merging has to be able to handle both the case where you add a formula and then you do some editing in the document that may affect what you need to select in the formula, so then you fix the selectors in the formula. You also need to handle the case where you sort of change the document, but then you add a formula that was written based on the original version of the document. And in this case, you need to edit the formula sort of behind the scenes as it gets inserted. The last interesting thing that goes on here is how this interacts with evaluation. So there's sort of two things interesting here. One that I mentioned initially is that another idea I've got is that in the document, you should not store just the final result, but we also want to be able to see how this got computed. And this is rendered in a sort of slightly shiny way here, but I can actually sort of see what was here before. So when I evaluate something, it sort of basically says replace the node, but what actually happens is that the new result, the new node, just gets appended as a more evaluated version. And I always show you by default just the most evaluated thing, but you can actually sort of go back in time and see, well, this was multiplication of two things. The first thing is 1000, and that was actually referenced to this. Second thing is number 3, which came from here, and this actually came from this calculation or this sort of counting. So this is one interesting thing that happens around the evaluation. The other thing that happens with the evaluation that's worth pointing out is that if so let me add the budget here and evaluate everything. And as you see, these sort of, what the evaluation does is that it really just appends more edits to the document. So the whole document is just edit history. I do highlight the evaluated edits, generated edits in gray. And so if I sort of do all these edits to my document and then add a speaker, then what happens? Well, this number 3 will be wrong. So let's do that. And the interesting thing that happens behind the scenes is that the adding of the speaker actually removed some of these generated edits from the document. So there were some edits in the history, but those are in conflict with the edit speaker with the add speaker edit, and so the generated ones get just deleted. And so what this does really is that it invalidates some of the previously evaluated things, and I have to re-evaluate them. It didn't invalidate everything. You can see that there's still 4 gray edits here, because the evaluation that calculated the refreshments and the bit that evaluated the travel speaker cost, that is still correct. That remains, but the number of speakers and the total speaker travel cost and the total cost is something I now have to re-evaluate. So again, this sort of representation of everything as edit history actually has this nice consequence that if I treat evaluation that way as well, I get invalidation of evaluated things for free. So somewhat contrary to the theme of this workshop, I'm not actually making this very live, but the point is this is sort of the infrastructure behind something that you could make live, for example, by doing the evaluation automatically, and because of this clever invalidation, it might actually be able to run faster. All right, last word I want to say. So normally people talk about future work to basically say, well, this is what I'm planning to do. Don't step on my toes. Do something else if you're working on a related project. My purpose here is completely different, because I really want to kind of get some feedback from people where this kind of thing might go. So please, I'll be hanging out in the Discord over the next couple of days. If you're interested in this, do come and have a chat with me. There's various things you could do with this, like do some formal proofs about this, actually turn it into a sort of usable projectional editor, rethink some more basic ideas about programming, or sort of add interactions with the user, which could also be added. So those are sort of some possible directions, but I'd be really interested in hearing what people think about this, or whether it sort of relates to anything you're doing. And I do want to mention that we also have some funding in Prague, where I moved recently, for both postdoc and PhD positions, with some interesting programming language people around. So if you're interested in these kinds of things, or are thinking about maybe going somewhere nice for a PhD or a postdoc, then please send me an email and we can discuss. So the conclusions, there's really two ideas here. It's this idea of working with documents, a theme of this session, and a bonus to that I'm adding is represent the program as a sort of edit history. And the idea is that, well, maybe this combination of these two things will let us realize something like what was the vision behind the early days of Smalltalk, but do it in a different way that will maybe let us solve some of the issues that Smalltalk eventually faced. Thank you.
Yeah, it's great. Great talk. I'm just looking around the room. Does anybody have questions now? I'll just start walking around with the mic here. I can also. Yeah, sure. Here you go.
Yeah, thanks for your talk. I found the idea of the evaluation as edits very compelling. Is there a way to intercept this? So as a user, for example, if there is a bug and like some value is not calculated correctly, that instead of fixing the program, I could like intercept the evaluation and like fix it myself in the concrete and then continue the program?
That's a good idea. In the current system, basically nothing works. The things I showed you are possible, and there's nothing else. In principle, this is something that I found very sort of potentially interesting, because you could, I think, edit the more evaluated version of the document at the point where the wrong value got computed, and then continue sort of evaluating further based on that modified state. I think this is something that we'd have to be careful about, because you want to highlight that the manually edited part is sort of inconsistent with the automatically evaluated part. But I think this is a sort of potential use of this representation that would be quite nice and practically useful.
I think if you think of the evaluator as another editor, it's an interesting model, because then obviously you can edit a human's edits, so you should be able to edit the evaluator's edits. Other questions in the room? There.
Hi, great talk. Very nice to see working demos like this. So your edits, are they like, can I understand them like they're designed as a sequential language of valid things that you can do to the document in order to update it? And could you then reason over how these edits work in terms of a language definition, do you think? Or, yeah, how would you reason about this?
Yeah, I think reasoning about this is an interesting challenge. So the sort of formal model of this really is you've got edit, and then the program is a sequence of edits. Mm-hmm. I guess a lot of the interesting, like safety properties, for example, if you wanted to say which edits are reasonable, they will have to deal with the fact that the edits are kind of replayed to construct the document. So you kind of, the properties, I think, would be hard to formalize just over the edit. You'd have to model the evaluation as well. And the edits, the way I have them right now, are very kind of low level. They're really like 3 edits on the document structure. Right. So maybe to get something more kind of semantically meaningful, we need somewhat more higher level logic. But you definitely would do the reasoning over this like sequence of edit operations, and you would formalize how these kind of transform the initial empty document into a current state.
Are you still there? Are you still there?
Yeah.
Oh, okay. We can't see you anymore. Yeah, tomorrow I'm giving a talk about something very similar. I'd love to discuss more with you.
What talk is that?
The Cascade one at SLE.
All right.
Send me a message on the Discord if you're able to access that.
Okay, Tomas, would love to talk more with you about this soon, but for now we're going to move on to our next document editing collaborative